It still catches some of your mistakes. And then it's a lot of no.
No, he did after. I'm gonna find that answer.
What'd you get? Oh, you're stuck.
Yeah.
So the first thing you,
No one say it.
I'm not going to say the answer, but you would start by whether they take English or not. So English, I think, is 1/3, if I remember right, which means no English should be 2/3. And then they either take math or no math. Math or no math. Like you started at least?
Yeah. Okay. I think I got it. Mr. Davis.
What?
Is that right? Please let me right.
You didn't finish. You gotta do way more than that.
Are you serious?
Yeah.
I'm confused because that's you just started English.
You gotta do those too, though. So he could enroll. We know he's enrolled in a math class. So you could be enrolled in a math class here or here.
Oh, never mind.
Forgot like that.
With a caption. Thank you.
So there's the, here, I'll try to do this. There's the chart for the top, or the tree for the top one. So that's not me giving you the answer yet, but that's, like, there's what your setup should be. What I did, I just kept it in fractions the whole time, because I'm okay with fractions, but you guys can use decimals. You just have to make sure you don't round too much. And then if you're doing fractions, when I got to this would have reduced. So I could have made that 2/5, but everything else was in 15ths, so I just kept it so it'd be easier to like combine them, you know? So just, or use decimals.
Okay, I'm done. Oh, I didn't even get a single answer that didn't on the paper. I give up. Never mind. I'm over it. No more.
How many have D on the bottom two and are comfortable with how they got there and feel like those are okay? And okay. Questions on, let's start with those two then, because they're definitely easier than the top one. Questions on, so 5 or 21, those bottom two? Where did you get this? Where did this happen? Alright, and the top one's tough. Fractions mess with people, and then it's the only one where you have to like combine stuff too. So, first of all, 1/3 of the time he takes English, which means 2/3 of the times he doesn't. If he does take English, you got this going on. If he doesn't, you got this. So you multiply them all together, and you might have decimals here. I don't know what the decimals are, so I can't like convert them for you, but you can put it in decimals. Just make sure you don't round. If it's 1/3 and you put 0.3, like that's a huge difference. So if you're rounding, go out, or if you're using decimals, go out like 5, 6 decimal places to make sure it stays like as close to accurate as you can. So then once I get here, the question is if we learn that he enrolled in a mathematics class, so I know he's in a math class. So then those two aren't even allowed to be in the game anymore. So I get rid of those. What's the probability he enrolled in an English class? So we want the total options on the bottom over success on the top. So how many total, if I add up all the times when he could be in a math class, so in my version it's 1/15 plus 6/15. So that'd be 7/15. And then how often is he in English in the English class would be 1/15. So this is 1/15, and then the 15s would cancel, and you would get 1/7. And then 1/7 is 0.143. And you can do the whole thing in decimals, and it doesn't look like these decimals are too close, so rounding probably isn't like a huge issue. Does everybody use decimals? So did you guys get like something really close to that? Oh, it's okay, so that's good. Okay. Does that help with people that were struggling with it? Questions on it? Do the first problem on the Frappy, please. On the Frappy packet. I know some of you are like quite caught up. I'll leave that up there just for a second if you want to copy stuff or look at it. So remember, out of your response, you want to show them what you're doing. So I think some of you are probably at the point on these where you're just kind of shortcutting a little bit, not necessarily writing everything out because you're kind of understanding it more. That's great on multiple choice. And for your response, you got to show them all your stuff. So the tree, completing the tree does count as like showing work. So if you just do that, you should be good. This is like the ones yesterday, but it's worded way friendlier because it doesn't say false positive, false negative. It actually like describes it. Look at this. I can't even keep it in the same problem. You can't see that. You know how I always mess up the words and the numbers? In the same tree, I can't even keep it straight. My nemesis. Need to all chip in and buy David some allergy moves.
Honestly.
I use these so much.
First star was the worst though.
So
Yeah, we're still.
what I'm talking about, I don't like try to see this without looking at the numbers. But what I'm talking about showing your work is I'm trying to show you this, not showing the answer. So do your tree, and then this part over here where you're writing out like the probability of disease n plus equals this. That's important. You have to show that as part of your work. And then if you show all that, you can just answer the questions. Yeah.
If I showed this is okay. Because it's more my thought process.
That's how I would do it too.
Okay.
like a perfect answer on the AP test. You got your tree up here, showing your multiplication, and down here you just like there's not a ton of work to show you. Just say, hey, I added these together and divided. What?
What?
You.
Yes.
Oh.
You have a look on your face.
I just got the wrong answer, so.
Is everybody else done?
Did you?
So what's the
Where's the
answer
answer
for
to
A?
the A? Never did the answer part. Never did the
Oh.
I didn't have any room up there, so.
Oh.
Are you done? Are you done? Did you get that? You got it? Okay.
It's the same.
Well, do you like the math stuff better? Some people love this chapter, and some people hate it.
I put my 95 on it.
This is easier than
But if you got this one,
No.
the highway one or something.
Yeah, I did that one.
so if you got this one wrong, but and it caused you to get this one wrong, this is correct, right?
Yeah, so there's another way the test, the grading kind of can help you out here too. If you make your chart or your tree and it's wrong, but then your answers are correct based on your wrong tree, they don't double jeopardy. There's no double jeopardy. So, like if your tree, like let's say you didn't know how to do the tree, but you know how to do A and B. I would literally go over here and write 0.25, 0.25, 0.25, 0.25. Just make stuff up and just take the L on that part. And then down here it'd be like, well, I know what to do after that. And you'd get like 2 out of 4. So they don't. So if this is completely wrong, but you know how to do those, you're still okay. You don't get 0 out of 4. That is nice. So if there's like a part B that you know how to do, but you don't know how to do part A, just make something up for part A that allows you to do part B and show them that you know how to do part B. How are we doing here? How many are still working on this one? Okay, that's fine. I didn't give you a ton of time. How many got it? Nice.
I just got a D in integrated math.
You don't have any. Oh,
Wait.
that's what it's called.
Wait. I have D. So apparently that was due yesterday.
Doesn't add up.
You did one of these pictures.
I
I didn't know that was due that day.
Yeah, let's see.
They agreed to it.
Figure about 2.0.
Well, there you go. What are these pictures?
I know.
Pictures of me?
Alright, go ahead and start the next one. But don't do part B. We haven't learned that yet.
So just
Can we try to do B?
Sure.
no.
I'll give you an answer.
I don't know if it's something that I would
You don't have to do B. You can try it. You might be able to.
I'll do A and C first.
What? Oh, that's what you're putting? I'll freeze this so if you're still working on A. That's quiet. I can do this.
No, I'm going to be crying to myself. Oh, we're just running out of the room.
Part A is pretty. Should be.
Is it just not all of it?
I mean, it's not easy. And neither of those are correct.
It's just a 0.84.
But I don't understand.
If everyone gets a flight or gets a seat on the flight, that means there has to be 38 people.
Or less.
Oh my gosh! So I was underthinking it.
Yeah, I wasn't sure if it was over or under.
So
38 people show up, everyone gets a seat, right? 37
Same with
people show
37.
up, everyone gets a seat. 36 people show up, everyone gets a seat.
So do we add the
Yeah.
probability?
So it's ors. So 36 or
Yeah.
37 or 38. Or means add. Who's talking about the expected number of no-shows? Did you hear me say skip B? You can try it, but you don't have to do it yet.
wouldn't it just be 0.84?
For which, are we still on A?
Yeah.
Good Lord, it's not supposed to be that hard. There's the...
Because there's a 60% chance that 38 people or more show up, isn't it?
No, there's a 46% chance 36 people show up. 30% chance 37 people show up.
Oh, I see.
16% 38 show up.
But what about 35, 54, and all that?
That would be.
Well, he's up to 1, so I guess that's 0. In this example.
Okay.
Are you know this one? So you're caught up. Probability you want is a decimal. Sometimes it'll say 1% chance, and then you make, then you make it a percent. So that first one, I don't know that.
Oh, what did you do?
I didn't mean for that to blow your minds. What did I do?
What's the or thingy?
Oh, okay, that's fine. So the plane holds this many people. This is the plane. It holds 38 people. So if 36 people show up, where everyone gets a seat, great. 37 people show up, oh, we have empty seats still. 38 people show up, everybody's good. So you just add those up. What did I do here? What's the or?
Oh, I see where you got the number.
I just subtracted the other ones. So it's just you can work it either way. I think this makes more sense to most people, but it doesn't matter. You do have to show, so the showing your work in this is the addition. If you just write 0.92, you're going to lose points.
Oh.
You got to remember these are the free response. They want to see your thought process. They want to see your work. So even if your work is just addition, put it down. So make sure you write that. Expect number of no-shows. If you want to try it, there's the answer. I'm not going to worry about it right now. And then this bottom one is, same stuff we've been doing. So given that not everybody showed up, so then not all the seats are full. So not all the seats are full means how many people showed up? 36 or 37, if not all the seats are full, right? So then the total possibilities are 0.46 plus 0.3. That's where I got the 0.76 from. And then what's the probability that 36 people showed up? That's the 0.46 that goes on top.
Did it right. Let's go.
How many had 0.605 there? Questions on it? Does that help? Where'd you get this? Why'd you put this here? Anything I can help with? Remember, these are test questions. I'll just change a number or something. I could just change that 38 to a 39 and make the whole question the same, for example. Your face. Anything I can help with?
McKenna sassy.
I know, that was
McKenna
sassy.
sassy.
Alright, try. You do not know how to do part B and C yet,
Yes. Go.
but I want you to try part A on the next one.
Are we just doing this packet for the rest of the day?
Yeah.
This one? Okay, this one.
We are going to learn how to do those, but it's not for 2 more chapters. So, probably. And then it'll be a review of part A, and then part B and C will be new at that point.
Ooh, ear infections.
You guys talk more about ear infections, please. It's not distracting anyone at all. Thanks.
It was distracting me.
That's what I said.
Now you talking about how you're not distracting me, now I'm distracting everyone else. Alright, now you're distracting me.
No, you're good.
You know how usually I just yell at the back corner? Trying to get to the back corner real slow. It's slowly morphing. I noticed it's better without Nathan. Remember when he went over there for like a week? He's like, I need to focus on my grades. And then like a week later, he's like, alright, I'm good. It's a little goofy one. You guys want some help?
It seems so utterly.
Plan 1. We're going to try. It's 2 different questions, yeah. So, plan 1, we're going to do antibiotic A first. So, it's either going to cure you or it's not. So, if it cures you, or what's the percent chance that, what's the probability antibiotic A cures you? 0.6. So, the chance it doesn't is 0.4. Now the tree up here stops. Because if you're cured, are you going to take antibiotic B? You're not. So this tree doesn't have 2 more branches up there, but this bottom one does, because now we got to try antibiotic B, which cures you 0.9 and doesn't cure you 0.1. So there's 2 ways you get cured. Either by just taking A and you're done, or taking A and then B works. So, like, what's the probability of yes of being cured from the top branch up here? It's just 0.6. What's the probability of, like, no then yes? It would be 0.36. Right? Did you do 0.4 times 0.9? What'd you ask?
How would you write this down? Like, A. You have to put A or A.
The whole thing.
No, like A. Like A and yes. Or just. Never mind.
So it's technically like probability of A. I mean, if I were being a little more specific, it'd be like probability of A, yes, equals 0.6. Probability of A, no, and B, yes, equals 0.36. Is that what you're saying?
Yeah, I just like I didn't put A. I was confused.
So then if I add those up, it's 0.96. Good? So then do the second one. Do like the other, flip it around. I think it's the same.
It should be the same.
Yeah. So then in part B, they're different costs. So in part B, they're different costs. And the final question is, which one would you use? You're supposed to say, well, since they're the same cost, I'll take the one that is more likely to cure me. They're the same cost. So,
Yes, the cost would actually be different because
the cost would not be different.
Yeah.
No, but let's say you took plan A or plan 1, you take the first antibiotic, which is cheaper.
Oh wait, the cost is different.
Yeah, the cost
There's
is
a lot of
different.
different.
But the probability should be of the 2 total.
So probability is the same. The cost is different. So
Yeah.
you cheap.
Cheaper one.
No, you'd have to know the probability that you
No,
spend.
there's a lot of different.
No, you'd have to find the
You
probability.
would take
that
the
you
one that has
spend.
the cheaper.
Yeah.
Not necessarily. I don't know, but you would take the one that is cheaper, probably a little bit longer. What if the first one is $1, but there's a 0% chance it cures you? You know, you wouldn't take the first one. Yeah.
But the thing is that if, let's say you get no on both and then you get yes the second time, you're still spending the same amount of money. Because you're taking both antibiotics still. If you get
So you might
no, then
you might as well
yes.
take
Say
the
you
cheaper
do
So
one.
you just do the cheaper one at
In
first.
this scenario,
Yeah.
yes. But not always, what I'm saying. So we'll talk about that more when we get to expected value. So for the plan 2, it's yes, 90%, no, 10%, and then you do the other one, which is yes, 0.6 and no, 0.4. So they get cured either there, which is 0.9, or there, which is 0.06. When you add those up, it's also 0.96. How many have 0.96 for the second? Okay, cool. Alright, try the back one.
Oh.
Yep. Part C is the interesting part. Part A, B shouldn't be too bad.
Oh, wait a minute.
You want me to put it back up or you good?
Oh, I see. I actually put 0.6 instead of 0.9.
Remember, show your work. All I mean for that was just show like the division. Like, it's not a lot of work, but you gotta put something.
But it's very easy just to.
It is. I assaulted you guys with some COD assignments. Sent you 8, I believe. Do you guys get notifications for that?
No.
Who does? I'm curious. Do you get 8 separate ones or just one? Like, you get 8 separate ones?
Well, that's me.
This morning. Really? Alright, I'll look. They're on here. Is dependent probability one of them? It is. Is probabilities of compound events?
Say yes.
Probabilities of compound events.
Yes.
Right. Good answer, I guess. So there's only 7 now. I signed an article. I don't even know how I would grade that. I deleted that. Yeah. Next Friday. So you have time still. We haven't covered all the stuff yet. That's probably around when your test will be too. Yeah. Alright. So part A, you're looking at just the overall big picture. 31 to 45, so there's 89 people that are 31 to 45. There's 207 total people. So you're showing your work, right? So you divide those and you get 0.43. And then the second one, they narrow down. They're like, all right, what if we know they're in the $50,000 category? So now they know we're just here, so nothing else in the chart even matters anymore. So there's 35 people that are between 31 to 45, 96 people. Divide those. So here's the question: are they independent? Does that mean that income and age are independent? So remember what independent means. If I tell you one thing is true, it changes the odds of the other thing. It gives you extra information. It would be dependent. So if I tell you you are in AP Stats, do you think being in an AP class is related to your SAT score? If I tell you you're in an AP class, that probably changes the odds that you get a higher SAT score than just someone that's not, right? That's dependent. So dependent is I give you a certain piece of information that changes the odds. Independent would be like your hair color and your SAT score. If I tell you a random person's hair color, does that give you any clue to their SAT score? No. So, in this case here, we went from big picture here to I gave you some information. I was like, here's some more information. I know that they make over $50,000. Did that change the probability? When I narrowed down my focus from big picture to here and gave you this extra piece of information, did that change the probability? It did. So independent or dependent? Dependent. So it asks if it's independent. So you say no, since the probability changes when we get the extra information. And put it in context too, right? So no, since probability changes when we know they're over 50,000. Does that last one make sense? Part C. So if they were independent, everything has to be the same ratio. This would be like 80 over 200.
Yeah, I got they were going after the fact that the probability was different, but I kind of guessed it for the no or yes part. My explanation was yeah, I got it right.
Alright, now when we're